Gravitation is a fundamental force of nature that describes the attraction between objects with mass or energy. It is responsible for the phenomenon of gravity, which is the force that pulls objects towards each other. Gravitation is described by the theory of general relativity, formulated by Albert Einstein in 1915. According to the theory of general relativity, gravitation is not seen as a force in the traditional sense but rather as the curvature of space-time caused by the presence of mass and energy. Objects with mass or energy, such as planets, stars, or even light, cause a distortion in the fabric of space-time around them. This distortion creates a curvature that influences the motion of other objects nearby. The fundamental idea behind gravitation is that objects with mass or energy tend to curve or deform the surrounding spacetime. When another object, such as a smaller mass or particle, moves in this curved spacetime, it follows a path that appears as if it is being pulled towards the more massive object. This apparent force of attraction is what we observe as gravity. The strength of the gravitational force depends on the masses of the objects involved and the distance between them. The force of gravity decreases with distance, following the inverse square law. This means that doubling the distance between two objects decreases the gravitational force by a factor of 4. Gravitation is a universal force, acting on all objects with mass or energy, regardless of their size or composition. It governs the motion of celestial bodies, such as planets, stars, and galaxies. It is also responsible for phenomena like tides on Earth and the motion of objects in freefall. It's important to note that gravitation is just one of the 4 fundamental forces of nature. The other 3 forces are the strong nuclear force, the weak nuclear force, and electromagnetism. While gravitation is relatively weak compared to the other forces, it becomes dominant on larger scales, such as the motion of celestial bodies, due to its cumulative effect over vast distances.